The catalytic activated vacuum distillation process, known as CAVD, is a newly acquired technology moving forward in the biofuel industry. The functioning process of a CAVD plant is to convert a waste product into usable forms of energy while obtaining carbon-based products from hydrocarbons. New Green Technologies has proven that it can utilize DDG as the fuel source for its batch reactors. Each CAVD plant operating at 48 tons of DDG per day generates an estimated $7.9 million in gross revenue, producing $3 to $4 million per year in net revenue. DDG chips are first loaded into the CAVD system using a front-end loader. The loader dumps the chips into a hopper where the chips are augered to the top of a transition chamber. The transition chambers are employed along with specially designed gates for both infeed of chips and discharge of solid products in order to maintain a vacuum throughout the system. Controlling the infeed chamber, sensors recognize when the transition chamber is full and trigger the valve to close off and the infeed auger to stop. A pump pulls vacuum in the transition chamber. The lower valve then opens and dumps the chips into a second inclined auger. As they travel up the second auger, the chips are metered to maximize throughput while maintaining proper operating conditions for quality control. Upon reaching the top of this auger, the chips drop into the continuously fed reactor. A series of band heaters span the reactor. Each heater is monitored and controlled independently by the temperature control panel. A number of thermostats help maintain the precise operating temperature as the chips travel through the reactor. If necessary, each heater can be replaced separately, allowing process operations to continue until the next scheduled shutdown. As the DDG chips reach the reactor, a proprietary catalyst is added. This catalyst enables distillation at a significantly lower temperature than would otherwise be required, resulting in higher quality of the recovered byproducts. Once the catalyst is added and the reactor is charged, the chips initially break down into gas and oil vapors. The gas vapors are drawn through a vacuum to the end of the reactor, where they are extracted. To clean the gas, it is drawn from the reactor into a hot oil gas purifier. The gas is funneled down to the bottom of the purifier and is bubbled up through the oil. This serves two primary functions. First, it cools the gas, condensing the heavier fractions directly into the oil, which flows over from the top and into the storage tank as the volume increases. Second, it filters the majority of the entrained carbon particles, which settle to the bottom and are periodically removed. The remaining gas then passes through a water-cooled condenser. Finally, the gas moves through a refrigerated condenser that further lowers the temperature of the gas. This final temperature drop strips out all the light and oils before feeding the gas to turbine generators, which produce most of the electricity needed to run the CAVD system. The CAVD system features several redundancies and backups for critical process components to ensure safe operation. Many controls are monitored both electronically and visually. Temperature and vacuum levels have digital and analog sensors to ensure proper shutdown in case of abnormal operation. A backup vacuum pump and electrical generator are on standby at all times. The system protects against and distinguishes any possible combustion inside the reactor. And finally, a series of relief valves are positioned at key locations to ensure that the allowable operating pressure of the system is never exceeded.